Welcome back to episode 2 of Spanning Tree. So, in this video, we are going to be doing our first test case, which is configuring a switch as the root bridge. So, right now, leaf 1 is the root bridge of this instance. So, I'm going to be configuring the spine as the root bridge. So, a root bridge election happens per instance. So, right now, I have one instance here. So, one instance in the sense is spine is running RSTP and both leaves are running RSTP. So all of them are running RSTP. So these are part of the single instance. Okay. So the election happens per instance. So right now leaf 1 is the root bridge because it has the lowest MAC address. So I'm going to be configuring now spine as the root bridge. So there are two ways to make a switch as the root bridge. One is configuring the lowest priority. The second is configuring the lowest MAC address. And we're going to be doing both options in this video. So let me go to my lab. I'm using a container lab again in all my videos. So let me show you the show spanning tree. Show spanning tree on the spine. Show spanning tree, leaf 2. Show spanning tree, leaf 1. So right now, leaf 1 is the root bridge. The reason is, as you can see, all three switches have the same bridge ID. So the tiebreaker is the MAC address, and leaf 1 has the lowest MAC address. So it is the root bridge. So now what I'm going to do is I'm going to make the spine as the root bridge by configuring the priority. So I can configure a lower priority than other switches. Right now, all the switches have the same priority, which is 32768. So if I want to make the spine as the root bridge, then I have to configure a lower priority than 32768. So spanning tree. So if you see, there is an option called priority. So I'm going to say priority, and the lowest priority that I can configure is 0, and the highest is 61440. So right now I'll have to configure lower than 32768, but what I'm going to do is I'm going to configure the lowest, which is 0. So let me do the watch command on both leaves. So now I'm going to configure the lowest priority on the spine. So the spanning tree should converge, and you should be able to see that on both leaf 1 and 2. Okay, so I'm going to configure the lowest priority on the spine. Now you can see spanning tree is converging. Now you can see the spine is the root bridge, and you can see the bridge ID or priority as 0, which is the lowest possible. So now spine is the root bridge of this network, and we can see leaf 1 and 2, we can see it's ET1 on leaf 1 and 2 are root ports, which is directly connected to the spine. And on the spine, we can see all the interfaces are designated in forwarding. So now I'm going to remove this. So this is the first and most common way to configure a switch as the root bridge. Okay, so I'm removing this this command, and you can see now leaf 1 has become the root bridge again. So I have another option, which is spanning tree root. So we can configure, we have three options. I mean, Arista has three options. So I can either configure a switch as a primary root, secondary root, or super root. And we are going to be configuring all three, and we'll see the difference of all three options. Okay, first, let me start with secondary. So you can see spanning tree is converging. So show spanning tree. And if you see closely, look at the now spine has become the root bridge. And if you look at the bridge ID, it is 16384. So which is, yes, it is lower than leaf 1 and 2, 16384. So that's why spine has become the root bridge. And we can see the MAC address is still it's still the same MAC address. Okay, so let me do this. Next one, primary. So now I configured the spine as the primary, and still the spine is the root bridge because it has the lowest bridge ID, because now the bridge ID is 8192. So with secondary, it was 16,000 something, and with primary, it is 8,000, 8192. Okay, and the MAC address is still the same MAC address. So let me do the super root. Now, spine is still the root bridge, and if you look at the priority now, with super root, spine has the lowest priority possible, which is 0. And there is one more subtle difference, which is the MAC address. If you look closely, the MAC address is 01, which is the lowest possible. So this is the lowest possible MAC address and lowest possible priority. So now spine says to every other switches that I have the lowest priority and lowest MAC address. So I am the superior. So it says I am the root bridge of this network. So because nobody else, no other switch can have lowest MAC address. Even if they have the lowest priority, they cannot have lowest MAC address unless somebody else configure that switch as a super root. And that is a human error. We cannot blame spanning tree for that. So even if somebody configures lowest priority on some other switch, the spine will still be the root bridge. Let's see that. So watch. So let me go to leaf one. Leaf one we know has the lowest MAC address. So now I'm going to say spanning tree priority. Now I'm going to configure the lowest priority on leaf one. Okay. Now show spanning tree. So now if you see, leaf one has the priority of 0. Okay, but the MAC address is still the same original MAC address, and you can see the spine is still the root bridge. The spine is still the root bridge. So even though now we have leaf one with priority of 0 and spine with priority of 0. So even if somebody else comes with priority of 0, because spine has the lowest MAC address, it will always win. Let me do one more test as well. Spanning tree root super on leaf one. Now, if you see closely now, I have configured the spine as the super root as well as leaf one as the super root. Now I have two roots, two root bridges in the same instance. And if you see closely here, spine, if you look at the spine, if you look at the interface ET1, which is directly connected to leaf one, it's backup and it's discarding. Okay, so it is backup and it is discarding, but because and the reason that ET1 on spine became the backup is because leaf one has the original lowest MAC address. So even though if you see both spine one and leaf one and spine have same 0 priority and lowest MAC address, but the actual MAC address when it comes to leaf one has the lowest actual MAC address. So ET1 on the spine is the backup, and it's still preventing the loop, but it's not recommended to configure two switches as spanning tree super root. It has to be this spine. We need to configure one switch. If the switches are in MLAG or something, then we have to configure the same on both switches. So it is always recommended to configure one switch as the super root. But even if we configure that, we can see that spanning tree still deducts that, okay, I have two super roots, but still I'm seeing both switches as the root. I'm seeing both switches as the root. And if you see, one more difference is that leaf one is actually isolated. Yep, we can see that. I just noticed that. Leaf one is isolated. If you see, all the interfaces on leaf one is designated, it is the root bridge, but leaf one is isolated from spine because ET1 is backup and discarding. And leaf two, if you see the ET3 and 4, which is connected to the connected to leaf 1 are alternative and discarding, and it has only one root port. The reason is a switch cannot have two root ports, because right now I have two root bridges in the network, and leaf 2 is connected to both switches. So it cannot elect two root ports. So it still selects ET1 as the root port because it was already configured as the root bridge, and ET3 and 4 is still alternative and discarding. Yes, yes. So it was an interesting um, test case, I would say. So I hope you have learned something in this video, and I will see you in the next video, which is episode 3, and I will be configuring root ports. So I will be configuring how we'll be exploring how root port election happens. So what are the criterias, and how to configure a certain port as a root port. So we'll be seeing that in the episode 3, which is the next video. And till then, bye. See you. Thanks for watching the video.